Okay, back again. This will be the last little video clip of the hardware. I did one showing the basic sort of layout of the board, all the various components as best I could. Another one showing the operation, transmitting on 20 and 40 meters and cycling around. And I thought I'd do a quick one at the end here just to show the bootloader operation. Now, just to reiterate what a bootloader is, there are two ways of getting the firmware. The firmware being is the terminology I'm using for the software that's running on the microprocessor here itself. So obviously it's blown into, well, not obviously, but it is blown into flash memory on the processor. There's two ways you can get the program on there. You can either use a PIC programmer, in my case a PIC Kit 3, and plug it into that header, plug the other end into the PC and flash the software that way, which is great. That's the normal way of doing it during development because it's quick. But that's not much use to anybody that doesn't have a PIC programmer. So say I was to release this chip or make program one of these chips up and give it to a friend because they want to make one of these Whisper boards. The chances of me not needing to upgrade the firmware is probably virtually zero. There'll always be a problem. There'll always be an update. There'll always be something that needs changing on the firmware. So if they don't have a PIC programmer, they've got to keep bringing the PIC back to me, which is inconvenient, obviously. So what a bootloader does is another piece of firmware which sits in the lower page of the, well, in this particular case, sits in the lower page of the PIC program memory, and it allows you to re-flash the firmware on the PIC. In this case, over this serial interface. So using this radio serial interface. It doesn't run particularly fast. I've deliberately slowed it down to improve the over-the-air integrity. It takes a minute or two to reflash. There's quite a lot of firmware. I've almost maxed out the 32K words on this processor. So the PIC, the application PIC, the bootloader application running on the PC connects to the bootloader firmware running on the processor. Once the connection is established over the serial interface, the PC application sends the new firmware over to the PIC. The PIC flashes its memory with it, and then the PC then reads all that back again and verifies it. It's just sort of two stages: flash and then verify. Okay. So to get it into bootloader mode, we use this little button at the top here. This button is either used to invoke a transmission mode when the board is standalone and not connected to the PC, or is also used to invoke bootloader mode. So the idea is you press the button, either power cycle the board or press the reset button. Essentially, when the processor comes out of reset, for whatever reason, if it sees this button pressed, then it says, oh, bootloader mode, enters bootloader mode and attempts to establish a connection with the PC. So without further ado, we'll put it into bootloader, and so that we know we're in bootloader mode, I've hijacked the top LED and relay. So the LED will come on saying we're in bootloader mode. It will go out when the connection is established, and then it will flash, and the relay will click when it's actually bootloading. Now people might say, well, why are you running a relay like that? Well, these relays are good for hundreds of thousands of iterations. 50 or 100 clicks during boot loading is not going to be a big deal. You don't boot load all the time. It might be once in a blue moon. So okay, put it into bootloader mode. So I press the button, hit reset. So the LEDs come on saying we're in bootloader mode. So I'll invoke the bootloader on the PC. So the bootloader application's up. Select the COM port, in this case COM port 6. Connection is established. So the PC application has said, yeah, PIC's responded, all good. Light's gone out. We got a connection. So the next step is to select the hex file, which is the firmware. In this case, it's the same firmware again, but it doesn't have to be. And press Program Verify. And away it goes. So the LED's flashing. You possibly might be able to hear the relay clicking if I shut up for 2 seconds. So the PC application progress bar is progressing, showing that the near 32K words of data have been transferred. So this is being transferred over the serial radio link. So if this WSPR Beacon was up a tree or something, or remote, you could reflash the firmware without having to form any physical connection to it. Obviously you'd have to put it into bootloader mode, but you wouldn't need a cable. So it's right. So it's finished the programming stage. It's now doing verification, which is approximately half as fast, because it's got to send a message over saying what bit of the program memory it needs, and then it reads back. The PC then reads back that part of the firmware and verifies it against the copy it just sent. Obviously the relay is being used as an audio feedback, but I mean we're not in any sort of transmission mode, because obviously at the moment we don't actually even have any firmware on there. If I hold the microphone next to the relay, you might be able to hear it a bit better. Cool, it's probably worked. So we'll just let that finish. So I didn't time the whole process, but it's probably a minute or so ish. It verifies the program memory and also the E² space and other sections of memory as well. Okay, complete. So the PC firmware is reporting arrays program verified completed successfully. So if I then press the reset button, there we go. I don't know if you can see that on the on the camera, but the software is running. So we've got what we had in the first video, which is just dashes for everything and the time, but basically the firmware is up and running. I pressed the reset button there. I could have also pressed the reset device button on the PC software, the PC application. Anyway, so that shows the bootloader. Anyway, any questions? Fire away. Thanks for watching. Cheers.